here's a problem that I'm going to use trig substitution for. So the integral of 1 over x cubed times the square root of x squared minus 1 dx. So I put on the side here what the trig substitution is. X equals secant theta. So you have got to do the derivative of secant theta. So, or the derivative, dx over d theta. What's the derivative of secant theta? It is secant theta, tangent theta. I was about to write d theta, but I got it right there already. So dx is secant theta, tangent theta, d theta. So every x will become secant theta, and dx will become secant theta, tangent theta, d theta. And I'm going to have 1 over, instead of x cubed, that is secant cubed theta. And this will be the square root of secant squared theta minus 1. Dx is secant theta, tangent theta, d theta. And I'll separate that thinking part. So this secant squared theta minus 1, there is a trig identity for that. And it's going to be what? Tangent squared theta. So this is the integral of 1 over secant cubed theta times the square root of tangent squared theta. And then I'll have times secant theta, tangent theta, d theta. The square root of tangent squared theta is just tangent theta. So I'm going to pull this part, secant theta, tangent theta, and write it in the numerator, although it'd be okay to leave it there on the side, but we're going to be doing some reducing here. So this square root of tangent squared theta is tangent theta, and then d theta. So I will reduce, and tangent theta reduces, and what else? That's secant theta over secant cubed theta. So this becomes the integral of 1 over secant squared theta d theta. Now, raise your hand if you know what to do from here. Okay. I'm looking at 1 over secant squared theta, and that is the same as cosecant squared theta. So this is the integral of cosecant squared theta d theta.
You're saying cosecant,
Cosecant?
yeah, that's cosine. You wrote cosine. I don't know what. Should be cosine, right? Wait, are we doing?
1 over secant squared theta is cosine. Did I say the wrong thing? Okay, all right. Okay, thank y'all for correcting that. So 1 over secant squared theta is the same as cosine squared theta. So now I have the integral of cosine squared theta, and this is one of those integrals I had warned you about. We had done, in fact, we had done some, I don't remember if it was sine squared theta or cosine squared theta, but here it is as a smaller part of a much bigger problem. And for this, I'm going to need the identity that is, this is the integral of 1/2 times 1 plus cosine 2 theta. So I'd have to remember that at this point, and let's factor out the 1/2. 1/2 times the integral of 1 plus cosine 2 theta d theta. That's really two separate integrals. You could write it as two separate integrals, or maybe you're comfortable just saying, well, I know what to do with this here. And the integral of 1 is going to be theta. So I'm going to put the 1/2 on the outside. The integral of 1 is theta, and the integral of cosine 2 theta, that's really a u substitution. But if you do this enough, you will learn that, let's see, the integral of cosine is sine, and because of the 2 theta, when you do the u substitution, you're going to end up with a 1/2. So it's 1/2 sine 2 theta. I'll put on the plus c there. And on this next line, I'm going to distribute the 1/2 that's on the outside here. So that'll be 1/2 theta plus 1/4 sine 2 theta plus c. Now, this is why I picked out this problem, because of the very next step. I have got to go back to x. And this sine 2 theta could be a little bit of a troublemaker. You got to know what to do with sine 2 theta right here. Because what happened here? We had this. X equals secant theta. And by the way, that is x over 1 is secant theta. And I'm going to draw the triangle. And in the triangle, I have theta. I do not have 2 theta. Secant, let's see, that's the reciprocal of cosine. I got it right that time. All right, that's the reciprocal of cosine. And so x over 1, that's hypotenuse over adjacent. So x is the hypotenuse, and 1 is the adjacent.
It's flipped, isn't it?
All right, so then Pythagorean theorem, you can find this third side, and that's going to be the square root of x squared minus 1, if you carry it out with the Pythagorean theorem. And I want to go back to x, and the problem here is I have 2 theta. So guess what? I need a trig identity for that. I need the trig identity, the double angle identity for sine. So before I can start substituting x back in there, I want to take sine 2 theta and write that as 2 sine theta cosine theta plus c. And then I can read my sine theta and my cosine theta from the triangle. And I'm going to have to read that theta right there. Well, look, if x equals secant theta, I could write that inverse secant theta, inverse secant of x equals theta. So I'll put that here. 1/2 theta is going to be inverse secant of x plus 1/4. I could have multiplied 1/4 times 2. Okay, sine is opposite over hypotenuse. So sine is the square root of x squared minus 1 over x. And cosine theta is adjacent over hypotenuse. And I'll put the plus c in. And you can simplify that a little bit if you like. You can multiply 1/4 times 2. I'm going to leave it at that.